In this video, I am going to explain Friedel acylation reaction. Friedel reaction was discovered by Charles Friedel and James Kraft in 1877. It is electrophilic substitution reaction. Electrophilic means electro means electron and philic means loving. Electron loving species, that is electrophile, the positive. When electrophile substitute on the benzene ring, here we take benzene and acyl chloride in presence of anhydrous aluminum trichloride at 80 degrees centigrade. It forms acetophenone and HCl and aluminum trichloride. Anhydrous aluminum trichloride means aluminum trichloride without water and moisture. How this reaction takes place, now let's see the mechanism. Step 1. Generation of electrophile. Electrophile, it is electropositive species. When acyl chloride reacts with aluminum trichloride, it forms acyl carbocation and Al4-. Al3 is an electron deficient species, and how this mechanism takes place. Now let's see here how electrophile generate. We take acyl chloride when react with aluminum trichloride. Aluminum trichloride is electron deficient species. It has 6 electrons in the outermost shell, and due to which it acts as a Lewis acid. The acyl chloride, the chloride atom has 3 lone pairs electron on it, and it donates a lone pair electrons to the p orbitals of the aluminum and form a coordinate bond with the aluminum trichloride. Acyl chloride, when form bond with aluminum trichloride, this carbon gets positive charge and the Al3 gets negative charge. At the time, the pi electrons present on the oxygen are shifted towards the carbon, and at the fraction of time, this Cl released from the acyl chloride and form Al3. And here acyl carbocation is present, are formed. Oxygen triple bond carbon CH3 and oxygen get positive charge. This acyl carbocation are stabilized by the resonance. This bond shift towards the oxygen and it neutrals the positive charge present on the oxygen, and due to which this carbon gets positive charge. Now let's see, look here, CH3C gets positive charge and double bond comes and double bonds oxygen. This is called acyl carbocation. It is also known as acylinium ion. When this acylinium ion is formed, is attack on the benzene ring. Now the second step is attack of electrophile on the benzene ring. Benzene, when react with the acyl carbocation, this pi bond shift, and this carbon gets negative charge and this carbon gets positive charge, and at a time this carbocation attack on the benzene ring. Now let's see the resonating structure. Now this acyl carbocation joins on the benzene, and this carbon get positive charge because double bond shift from here, and this positive charge are neutralized by the this pi electron shift towards this positive charge and neutralize this positive charge and form a double bond here. and a double and positive charge comes on this carbon. Now the second resonating structure will be positive charges here and double bond form here. Due to neutralize this positive charge, this double bond shift towards here and we get positive charge on this carbon and a double bond form on this. Now the next structure we see double bond here, and to neutralize this positive charge and form double bond here, this proton is released from here and double bond form here and we get acetophenone. Now look, now we see double bond form here and we get acetophenone. Acetophenone is also known as methyl phenyl ketone. It is, now let's see alpha complex structure. Alpha complex structure is equivalent to these resonating structure. Now these pi bond resonate here and positive charge present here. This is known as alpha complex. These resonating structure 1, 2, 3 are known as adenine ion or sigma valent complex. Now we come to step 3, removal of proton and regeneration of LCl3. Now we take this structure. In this structure, when AlCl4 minus comes to react here, this proton shift from here and our Cl molecules comes from released from AlCl4 minus, and these are formed hydrochloric acid, and this compound form acetophenone and AlCl3 release out. Some people think that when this bond is formed in acylation, this reaction stop here, but it's not done. Let's proceed further. This reaction proceed. How? Look, see, lone pair present on the oxygen and L3 further comes to take this lone pair. L3 take this lone pair electrons and form a bond with the acetophenone. AlCl3 is an electron deficient molecule and it is called Lewis acid, and this acetophenone is an electron rich species and it can donate electrons, so it is known as Lewis base. These acid and base are form a complex known as we can say salt. When this salt is formed, the reaction gets stopped here and it freezes. And further, when we hydrolyze this complex, it gives acetophenone. It hydrolyzes from here and it gets acetophenone from here and gives ammonium trihydroxide, and 3 molecules of chloride forms 3 molecules of HCl. Now this reaction is complete here, and like acyl chloride, there are many reagents which act as acyl chloride. It is acetic anhydride. Acetic anhydride when react with benzene in presence of ammonium trichloride, it forms acetophenone, acetic acid, and 3 molecules of HCl and ammonium trihydroxide. How acetic anhydride react with benzene? Now look, we see here. This is acetic anhydride CS3 is 3 double bond O and C double bond O and CS3. LCl3 come and take this pi electron, this pair electron present on the oxygen, and it form a complex, and when it link with here, this bond is this carbon gets positive charge. When this oxygen gets positive charge, simultaneously these lone pair electrons which are present on oxygen are shoved here. At the fraction of time, this bond is dissociated and acyl carbocation are formed. Acyl carbocation CH3 C double bond O plus. Now a byproduct is also formed, which is CH3 C double bond O and LCl3, which shown here. CH3 C double bond O and LCl3, it is byproduct. Then this acyl carbocation acylinium ion is formed. It attack on the benzene ring and it stabilized by resonance, and is at last it gives the acetophenone. Here I am not shown the resonating structure of this. When we get final product acetophenone, then further Al-3 comes in contact with acetophenone, and the pi electron present on the oxygen it takes and form a salt which is present here. Salt is, when we hydrolyze this salt, we get acetophenone from here, acetophenone and aluminum trihydroxide and 3 molecules of AlCl3, and this byproduct also hydrolyzed. When this hydrolyzed, from here we get CH3 C double bond OH acetic acid and aluminum hydroxide. Now this reaction completed here. Now we take another reagent in place of acyl chloride, which behave like acyl chloride is that this product CH3 C double bond O and C double bond O and CH3, in place of 2 hydrogen we attach 3 methyl group here. Now this is a problem that if this bond break from here, we get acylinium carbocation, and if this bond breaks from here, we get this electrophile. But problem is that which part form the electrophile. So in this molecule we say so less hindered portion will be electrophile, less static hindrance. This portion C double bond O and CH and CH3, here 2 methyl group are present, so this portion is very hindered, has more static hindrance, and this portion has less static hindrance. So it is less static hindrance portion, so acyl carbocation formed from this portion, and then it attack on the benzene ring and form acetophenone and these molecules and AlOH whole thrice and 3 molecules of chloride. Now guys, please subscribe my video and like. If you subscribe my video, you get my next video on your